just going to start with a reminder that when we're combining like terms with equations like this, we can only combine like terms that are on the same side. So if they're both on the left side of the equation, we can combine them, or if like terms are both on the right side of the equation, we can combine them, but we cannot combine like terms across an equal sign. To do that, we have to actually solve the equation and use inverse operations. For example, like in number 1, 2x and x are like terms, but they're on opposite sides of the equal sign. So we can't just combine those and say 3x, but we can use inverse operations. So anytime we're looking on opposite sides of the equal sign, we have to use inverse operations. So just like how we would, like if I wanted to, for example, move this 9 over, the opposite of plus 9 is minus 9. But that's not going to help me this time because there's no constant or like term for that on the other side. So we're going to actually use the same process as that, but we're going to do it with the x's. So I need to get both of these x's to the same side. We typically want to have all the variables on one side and the constants or plain numbers on the opposite side. So since my number is over here on the right, let's move my letters over to the left. So I need to get this positive x. Opposite of positive x is negative x. So I'm doing negative x on both sides. Remember, what I do to one side, I have to do to both sides to keep it balanced. And just like when we undo adding and subtracting, this should make 0. A positive x and a negative x, that makes 0, so it cancels out. And then 2x minus x, which remember, this is really 2x minus 1x, is 1x. And we don't typically write the 1 when it's a 1 in front, so I can just say that that's x, is equal to, now we haven't touched that 9, so the 9 is still there. So we have x equals 9. On number 2, since my constant is already over here on the left, I'm going to go ahead and move these letters over here to the right. So then to do that, we're going to have to use inverse operations because they're on opposite sides of the equal sign. So I need to move this positive 1/2 x to the other side. So the opposite of a positive 1/2 is a negative 1/2, and then a negative 1/2. This should make 0. Positive 1/2, negative 1/2 makes 0, so that cancels out. I still have a negative 3 on this side. Remember, when we haven't used a minus sign, that just stays attached to the next number, becomes negative. So on the right hand side, I need to do some scratch work. I need to do 3/4 minus 1/2. Well, to subtract fractions, we need a common denominator. So I can leave this as 3/4, and I can multiply these both by 2 to make that 2 over 4. So now I've got my common denominator. 1/2 became 2/4. And now I have a common denominator. I can do my subtraction. 3/4 minus 2/4 is 1/4. So that's 1/4 x. And now that all my variables are on one side, all my constants are on the other, I can begin solving this some more. So now we're going to do just how we would normally. This 1/4 is multiplying x, so the opposite to divide by 1/4 on both sides. Divide by 1/4, which is 1 because it cancels out. I'm going to do some scratch work again. So what we have is we have negative 3, and we have to divide that by 1/4. Let's make that a fraction, negative 3 over 1. We're going to do keep the first fraction the same, change to multiply, and flip, take the reciprocal of the other fraction. Then we'll multiply straight across. Negative 3 times 4 is negative 12. 1 times 1 is 1. And negative 12 divided by 1 is just negative 12. So negative 3 divided by 1/4 is just negative 12. On number 3, I notice I've got constants on both sides and variables on both sides. So I can actually choose. I could choose to move this 4x over here, and that would put all my variables on the left, so I would want to move the constants to the right. Or instead, I could go the other way, and I could choose to move the 2x over here, and put my variables on the right, then I want my constant to move over to the left. It does not make a difference which way you go. I tend to like to have my variable on the left, so I'm just going to go with that, but you do not have to make that same choice. So I'd like to put my variables on the left. So to do that, I need to move this 4x over. Opposite of 4x is negative 4x. And what I do to one side, I have to do to the other side. Always underneath the like terms. 4x and negative 4x cancel because that makes 0. 2x minus 4x is negative 2x. And then I still have that plus 3, so drop down the plus 3 equals, and still have that positive 5. Now this should look more like a normal two-step equation. I can continue solving. So we brought the variable to the left side, which means I need to move my constant over to the right side. Opposite of plus 3 is minus 3. What I do to one side, I have to do to the other side. This cancels because it makes 0. So I have a negative 2x is equal to 5 minus 3 is 2. Now I got a one step. Opposite of multiplying is to divide by negative 2. And x equals 2 divided by negative 2 is negative 1. On number 4, I notice a couple different things. I'm noticing I've got distributive property on the left, so I'm going to do that. 2 times 3x is 6x. 2 times negative 1 is negative 2. On the right side, I'm noticing that I have some like terms, an x and another x. And because they're on the same side, I can just go ahead and combine those like terms. Negative 4x and an 8x is a positive 4x. Now I have variables on both sides. If I were to move this 4 and do minus 4x on both sides, this would cancel. And there'd be nothing left over here, which you can do. When there's nothing left, you just say there's 0 left. That's actually creating an extra step. We'll go ahead and finish solving it like this, just so we can see. 6x minus 4x is 2x, and then I still have that minus 2 that I need to bring down. And then I can continue solving this 2x, so I would add 2 to both sides. 2x is equal to 2. Divide by 2, x equals 1. If this 0 confuses you, let's solve it a different way so we can avoid getting that 0. Another way we can do this is if I notice that if I move that 4x over, there'll be nothing left. Instead, I can switch gears and I can say, well, let's move the 6x over then by doing minus 6x. I'm still going to have that negative 2 that needs to drop down over here. 4x minus 6x is negative 2x. Divide both sides by negative 2, and x equals 1. So we're going to get the same answer either way. This actually does it in one less step, but it is okay if something cancels out. If you have nothing left on one side, make sure you put that 0 there to show that there's a 0 left on that side. A common mistake is to move the equal sign instead of putting that 0 there, which you cannot just move an equal sign. Okay, now we're going to look at our word problem. Your long-distance telephone provider offers 2 plans. Plan A has a monthly fee of $15 and 25 cents per minute. Per minute usually tells me I'm going to multiply, and we'll use m for our variable. So 25 cents per minute, so it means 25 cents per the number of minutes that I use. Plus, I'm also paying that $15 fee. So that's plan A. Plan B has a $20 fee and 5 cents per minute. So I have 5 cents per minute, so 5 cents times each minute, plus that $20 fee that I'm paying. And if we keep reading the problem, it says write and solve an equation to find the number of minutes that you must talk to have the same cost of each of the plans. So if they have the same cost, that means they have equal cost, which means plan A and plan B have to be equal to each other to have the same cost. So now we've got our equation. Just like we did before, we want to get all the variables to one side. Again, I like to get my variables to the left, so I'm going to move this by doing negative 0.05 m to move that to the other side, negative 0.05 m. This makes 0, so it cancels. So I just have that 20 left over there. I'm going to drop down that 15. And then I have that 0.25 minus 0.05, and that is going to give us 0.2 or 0.20, depending on which way you like better. And now I just got a regular two-step equation I'm going to solve. So the opposite of plus 15 is minus 15, because we're going to undo add or subtract first. That gives me 0.20 or 0.2 times the minutes equals 20 minus 5 is 20 minus 15 is 5. And then our last step is to divide both sides by the 0.20 or 0.2. And if I take 5 divided by 0.2, we get 25. And remember, M stood for minutes. So it says, find out the number of minutes you must talk for the same cost. So 25 minutes. So either plan, if I talk for 25 minutes, that'll be the exact same cost. So when we're solving equations with variables on both sides, remember you want to get the variables to the same side. You're going to use inverse operations, either add or subtract the opposite to move it either to the left or to the right. It's up to you. And then once you got the variables on the same side, then you're going to continue solving like normal.